Hello everyone. So today we are going to tackle the theoretical side of the bisection method for finding the roots of polynomial equation. So in this video, we are going to cover only a theoretical portion of the bisection method, and next video is going to be upon the numerical solving part. So let's break down the theory behind it. So now moving forward to the bisection algorithm definition part. So it is a numerical algorithm that is we use to find the root of the continuous function within a given interval. So it is one of the most simplest and most reliable iterative method that we use to find the roots of a non-linear equation. So what we do in this method, we take two interval point. Let us suppose we have interval point A and B, and we are going to divide these two interval into half. This is going to give us this value of C. We can see in figure that we have provided 2 point A and B, and by dividing into them half, we are going to calculate the value of C. And after this step, we are our root is going to lie between this interval or either in this interval. So we are going to see in our numerical calculation part how we are going to calculate this A and B value, and using this A and B value, how we are going to calculate the value of C. So this method is also known as binary chopping or half interval method. This is one of the most important line, that it is also known as binary chopping. So chopping is defined as that something we are dividing into half. That is why it is known as binary chopping or half interval method. This process continues until the interval becomes sufficiently small. Till the point our interval becomes sufficiently small, or sometimes it is given in the question that till this iteration you have to done your calculation, like you have provided up to fourth iteration you have to calculate the value of that root. So as we are going to divide our interval into half and half again and again, that is going to be smaller and smaller, and we are going to get the most accurate value of our root. So that is why this method is sometimes very time consuming. It is going to take very large amount of time to calculate the root of our function. So after that, this definition part, we are going to see the algorithm, how we are going to actually calculate these values of A and B. And after that, in the next video, we are going to see how we are going to solve the numerical based upon the bisection method. Now again, a whole bunch of theory. So, but this is very simple. There are only 4 steps involved in the calculation of root in using the bisection method. So first step is going to be our initialization step, then iteration step, then our termination step, and at the final we are going to get our roots. So what does the initialization step says that we are going to choose two initial points A and B such that the function changes sign between them. How this is going to be happen, that we are going to calculate the value of our f of A, then f of B, and we need one of them function to be negative. If I say that f of A, I got f of A as negative and f of B as positive, so that value is going to be less than 0. But if I got f of A as positive and f of B also as positive, that value does not satisfying the need of our initialization step. So using this following approach, we are going to calculate our value of f of A and f of B. They are going to give our two interval point A and B. So then we are going to see in our iteration method that we are going to follow for multiple time that we are going to calculate the midpoint C between these interval. Using these interval, we are going to divide A plus B divided by 2. That is going to give us the C point. And we are going to put that C in our function, and we are going to see the sign of that f of C. If our f of C becomes equal to 0, then that is our root. We have got our root in one step, single step only. But if that is not equal to 0, and we have multiplied the function value of A and B, the function value of C, we are going to see that value is less than 0. If that value is less than 0, our root is going to be lie between this provided interval A and C. But if that is not the case, if our f of B and f of C is becomes less than 0, then our root is going to be lie between this interval C and B, and we are going to follow this step multiple times till the point our root become very sufficiently very small, and that is going to give our most significant or most accurate value of our root. So if I say I follow the step multiple times, if I calculated the root multiple time, at a particular time I am going to be very close, particularly very close to a root. That is particular value is going to be our root. Sometimes it provides in question that you have to calculate till fourth. You have to calculate till the fourth approximation or third approximation or third. Sometimes it is written that second iteration. So that is going to be reduce our burden of calculation. So our third step is going to be this termination step. We have to repeat the iteration until the desired level of accuracy is achieved, or until a maximum number of iteration is reached. And after that, the iteration, the midpoint of the final interval, we are going to take as the approximate root of the function. That is going to be our root, and we are going to see that is going to be our whole of process of calculating the root using the bisection method. And we are going to see also the advantages of bisection method. So I have written down the third and the fourth step of our bisection method algorithm. Now moving forward to the advantages and disadvantages of the bisection method. So advantages say that in this we can manage our errors by increasing the number of iterations in the bisection method. We can it can always result in a more accurate root. Next one is that it does not demand complex calculation. We know that we have to only divide our a plus b value divided by 2, and that is the simplest step we have to do only, and it is most simple and straightforward algorithm. And what are the disadvantages of bisection method is that it has a slow convergence rate. It has a very slow convergence rate because we have to perform multiple steps for to get our root, and its inability to detect multiple root. These are the two main disadvantages of bisection method. So in this video we have covered all the theoretical part of the bisection method, and in the next video we are going to solve a numerical based upon the bisection method, and we are going to see how we are going to choose our interval values. Using these interval values, how we are going to calculate the value of our c, and till which approximation we have to calculate our values, or how we are going to calculate our root in the end. So that's all for this video. Thank you.